All right, here are our objectives for 5.1. For 5.1, we need to be able to determine whether an ordered pair is a solution to a linear system. I mean, I'll do examples for you on that one, but I think that's fairly obvious, right? How do you do that? Plug it in, right? Plug it into the system. What has to be true about it? For every single equation, right? Not just one, but every single equation that's part of the system. Solve linear systems by substitution. I'll do an example or two for you of that. Solve linear systems by addition. They call it addition. We called it elimination. Okay, so this is definitely something you already know how to do, but again, I will show you some examples. Identify systems that do not have exactly one ordered pair solution. We'll talk about that a little bit. And then solve problems using systems of equations, which means word problems, right? Okay, so 5.1. What if we have, well, I'm going to do this just so that we can say that we've done it, okay? X plus 2y equals 2. X minus 2y equals 6. And my question to you is, for negative 1 a solution to this system? So we substitute it in, right? Okay, so 4 minus 2 equals 2. 4 minus 2 is 2. Does 2 equal 2? Yeah, so it works for the first equation. What about the second equation? 4 plus 2 equals 6. That works, so yes, this is a solution to this system. Does that make sense? Do I need to do any more of those? Fairly confident about those. Okay. Before we go too much further, I want to make sure that we remember some things. Okay. If we have an x and y axis like this, there's a couple possibilities that we can have. If we're talking about linear systems, what do I mean by a linear system? Lines, right? Two lines. I can have this line and I can have this line. How many solutions are there to this system? One. And where is it? Right here. Okay, there's one solution. You remember this, yes? Okay. Another option I could have is one line here and one line here. How many solutions are to this system? No solutions. Why no solution? Because they don't ever cross, okay? We can have this, and then we can have this. I think infinitely. You know when you write something and it looks wrong and you don't know if it's wrong or not? Is infinitely right? I'm pretty positive it is, but ugh. Okay, so any point along this line is also on the other line. So any point is a solution to the system. Okay? Just making sure we remembered that, right? So what if I give you this system right here? 5x minus 4y equals 9. And x minus 2y equals negative 3. How are we going to solve that system? What if I ask you to solve it by substitution? So we're going to solve for a variable. Why do you want to choose x in this case? Seems easier, okay? So we're going to add 2y to both sides. So x equals 2y minus 3. Can you please tell me why I wrote 2y minus 3 instead of negative 3 plus 2y? Yeah, that's pretty much the only reason. Could you have written negative 3 plus 2y? Absolutely. Okay. Now that I know what x is, what do I do with it? Take it to the other equation right up there, right? Okay. So 5 times what I know x equals, 2y minus 3, then minus 4y equals 9. And that's an equation I can easily simplify and solve for. So 10y minus 15 minus 4y equals 9. So 6y minus 15 equals 9. If I add 15 to both sides, 6y equals 24. If I divide both sides by 6, y equals 4. Am I done? Wait, what? What am I looking for? I'm looking for, if possible, the point of intersection, right? That's what I'm looking for. If I find y, that's great, but what I'm looking for is the whole point, the x and the y. Okay? So if I were you, I would go right over here and plug substitute what I found y to be into that, because I already have x solved for here. So x equals 2 times 4 minus 3. So x equals 8 minus 3, so x equals 5. Now what is the solution? 5, 4. And at this point we could check it, right? We could substitute it back into the original two equations. So 25 minus 16 equals 9. Or 5 minus 8 equals negative 3. Yeah, they both work. I know it's the correct answer. Okay? Here is another example. 3x plus 2y equals 48. And 9x minus 8y equals negative 24. And I would like us to do this problem by elimination. We call it elimination. In this textbook, they call it addition. Okay, but it's the same kind of concept. We're trying to eliminate one of the variables so that when you add them together, add the two equations together, one of the variables eliminate. So which variable would you like to eliminate? Do the x? Doesn't matter. No, it doesn't. And in this problem, if you want to be technical, I probably would have solved for the y because they're already opposite signs. But you said x, so we're going to solve for x. Is that all right? To eliminate the x's, what are we going to multiply by? Negative 3. So if I multiply the whole top equation by negative 3, I get negative 9x minus 6y equals 48 times 3. 144. And then I have this original second equation that I'm just going to write down. Okay? So now here's where the name addition comes from, because now you add these two equations together. Okay, that's a 0, that is negative 14y, and that is negative 120. Pretty positive. But I also know the answer is, thank you. Yeah, you guys know negatives are my nemesis. So how about negative 148? Now to solve, I divide by negative 14. That's still not the right answer though. Say again? I still can't hear you. Where? Oh, I'm an idiot. So 168 divided by negative 14? 12. I'm sorry, I apologize for my, I don't even know what to call that, dumbness. I miss the sign, then it throws me off because then my brain is like, freaking out, so I'm sorry. Okay. So now that I know why, what do I do with it? Which one would you plug it into? Probably the top one, okay. So 3x plus 2 times 12 equals 48. So 3x plus 24 equals 48. The 3x equals 24, so x equals 8. 8, 12. And of course we would want to plug it back in. 16 plus 24 equals 48. Not 16. 24 plus 24 equals 48. So that one's correct. And then 72 minus 8 times 12, 90 something, equals negative 24. it does. Okay? You alright with that? Any questions about that so far? Is any of this new? No. Okay. Just new when I mess up. Feel like a fool? Excellent. 15x minus 5y equals 10. You can solve this any way you want. What's your first inclination of how to solve it? Substitution would probably be easier because this is already solved for y, right? And just plug everything right here, substitute everything right here straight for y. So 15x minus 5 times 3x minus 2 equals 10. So 15x minus 15x plus 10 equals 10. 10 equals 10. Does 10 equal 10? So what do I do? Did I do something wrong? I did not. It is. It is infinitely many solutions. How would I know the difference between infinitely many and none? No solution. What would it look like if it was no solution? (4x plus 6y equals 12). 6x plus 9y equals 12. So let's solve this one. Elimination? Which one do you want to eliminate? If I eliminate the x's, I could get them to 12, right? Okay, so 3 and 2, so probably negative 2. You okay with that? So if I do that, I get 12x plus 18y equals 36. And I get negative 12x minus 18y equals negative 24. 0 equals 12. Does 0 equal 12? Will 0 ever equal 12? Do you see the difference? This one's no solution. This one's infinitely many solutions because this is a true statement and this is false. Okay? Does that help? Do you have any questions on 5.1?